Scientists have known for a long time that global warming can be expected to increase extreme precipitation. However, what's really challenging is that at the regional and local scales that really create flooding, these are often very complex processes that create those extreme precipitation events.
We focused on the US Midwest region because this is an area where there is a lot of flooding. We wanted to understand both changes in sort of atmospheric temperature, so a warmer atmosphere that can hold more moisture. This can lead to more extreme precipitation, but we wanted to also look at how changes in the atmospheric circulation could be changing the frequency of these events. The model that we use can analyze basically weather maps, so variables that have a lot of important spatial information, and the model learns to identify the specific spatial patterns that lead to extreme precipitation over the Midwest.
What's clear from this research is that we're now in a climate where the kinds of weather patterns that have produced extreme precipitation in the past are now producing more precipitation than they used to. And that elevates the risk that the precipitation is actually more than what we're prepared for. That's relevant in the short term for evacuation, for example, for individual events. It's also relevant in the long term for how we plan for increasing extreme events overall.
One of the challenges when we design infrastructure like bridges or roads, and also design where to build houses, we expect that to be in place for a long time. And so if we want those buildings and that infrastructure to withstand floods, we need to be able to predict what floods will be like pretty far in advance. And I think so far we've focused on the historical period, but the goal is that we could also use this method to get a better understanding of how these events will change in the future.